continuing our discussion on DynamoDB indexes. So I'm going to share very interesting tips and tricks to make best use of DynamoDB indexes, whether it is GSI or LSI. In case you are not aware about GSI or LSI, please watch my other videos where I have covered GSI and LSI in detail, and I have showed the demo also that how we can create GSI and LSI. Now, coming to DynamoDB indexes, that how can we make best use of this, right? So it is possible that we can reduce the cost of GSI or LSI. We can reduce the storage space required for GSI and LSI. So we can design our indexes in such a way that storage space as well as cost along with RCU, WCU cost is kept as minimum as possible. So there is a capability in DynamoDB indexes which we can leverage to have all these best practices in place. So I'm going to share a couple of such practices in this video which will help you to design DynamoDB in an efficient and cost effective manner. So first thing which I'm going to share is sparse indexes. If the sort key does not appear in every table item. So here it could be sort key in case of LSI as well as it would be partition key and sort key in case of GSI. For example, if a table has 10 records and out of those 10 records there is GSI which we have created is having values only in 5 records, then we will say that that index is a sparse index. Now you might have guessed it correctly that if GSI is present in 5 records instead of all the 10 records, we have saved our cost. Read write capacity units requirement is lesser than the all the records. By default, global secondary indexes are sparse. We must strive to design secondary indexes to be sparse, which will result in lower write throughput. Example could be an intermittent attribute deleted after its purpose is fulfilled. For example, is open field for order status or service request. So in case is open field we have kept for the orders, right? And once the order is fulfilled, we can simply remove this field. And this could be a sort key or this could be a partition key as well as sort key in GSI or LSIs, right? So I have created an example also here. If you see here, here I have a table which is having students data from different classes, student 1 in class 8, student 1 in class 9. Out of these, I have kept a field called quiz prize winner which is having value y. So we can say that this attribute is sparse. Now if we create a GSI or LSI with this as a sort key in LSI or GSI, we can simply say that this is my partition key. Then I can say that I want to fetch all the students who have won the prize, or I can keep a year also in addition to this column, which will help me to find out the students in a respective year that who have won the awards. So by making use of sparse indexes or by designing GSIs or LSIs in such a way that those act as a sparse index, we can achieve a lot of efficiency in DynamoDB indexes. The second one is aggregation. We can maintain near real-time aggregation with the help of DynamoDB Streams. So don't worry in case you are not aware of DynamoDB Streams that I'm going to cover in my future videos. But for now, what you have to understand is as soon as the data is entered in a DynamoDB table, some event is triggered which can lead to an action on that item. We can create some AWS Lambda function which will be called once the data is entered or updated or deleted in this DynamoDB table, and we can perform some aggregation store again in the table so that while showing the aggregated results, we can directly refer that record rather than creating those aggregations at the time of request, right? For example, so if you see in this screenshot, you can see music library table is there. Partition key is the song ID and sort key is details, which is basically download ID. We are keeping a track of how many times this song has been downloaded, right? By keeping a track of download ID and time of download, right? Now we want to see how many times this song has been downloaded in the month of January 2018. We can store it like this, right? Here, which is month, and here we have aggregated value of all these downloads for this month, right? We are updating this in such a way. And same way, this at the top level, this is again song detail, which is title, artist. Again, here we are saying lifetime total downloads. So this kind of aggregation can also be done on top of DynamoDB indexes, which will help us to avoid unnecessary and irrelevant read consumption through this table. So in case there is a use case which requires aggregation on top of your indexes, so we can do aggregation in such a way. Moving on, third thing is GSI overloading. So DynamoDB has a hard limit when it comes to GSI, number of GSIs. We cannot create more than 20 GSIs. And as per my observation or analysis or experience with DynamoDB so far, in case we are creating 20 GSIs on DynamoDB, it is going to be a lot expensive, as well as in case there is a requirement to create more than that, right? It's not possible. So only option left is GSI overloading. Let us see how it looks like. GSI partition key, sort key, and GSI sort key is the data attribute. So here in this case, we are having this sort key acting as the partition key of GSI, okay? And the sort key of the GSI is this one. So this one is the partition key of GSI and this one is the sort key of GSI. Now let us see what this overloading help us in. Look up an employee by name in the global secondary index using employee name as the partition key value. So this is our employee name. We want to fetch the detail of this employee, right? This can be easily done. If we don't overload it, we will have to create a field called employee name, and there either we will have that as the new GSI, right? Like that we will have to do. Use this global secondary index to find all employees working in a particular warehouse. So I can easily find out that how many employees are working in a single warehouse with the name, right? That is what it's saying, working in a particular warehouse. So I can easily find out, get a list of recent hires by finding out HR confidential and giving the date range. I can write between and other operators also that I have shown in my other video. So that is how we can make best use of DynamoDB indexes. So I have seen people who have been saying that DynamoDB may not be a good option. We have the skills to design the DynamoDB, if we have understood the internals of DynamoDB or the best practices which I have just mentioned for DynamoDB indexes, we can make best use of DynamoDB indexes. That is what I can guarantee. Though I am sure that DynamoDB may not be a best fit for all the use cases, but it can be modeled in such a way that it is giving us best possible results in terms of cost as well as storage space also. So with this, I would like to end this video here and look forward for your feedback on especially this video, because this is going to be very beneficial for all the DynamoDB users who aspire to learn DynamoDB internals as well as who are willing to reduce their existing cost of DynamoDB. So looking forward for your feedback and see you in my next video. Thank you so much.